All right, I wanted to go ahead and take a look at the practice test, and I'm looking at question number 1. So, we have two objects, and we've plotted their position versus time. And if you notice, this is the constant velocity, distance, and displacement section. And on your real test, I'm going to actually have you choose 3 of the 4 questions that I have here. So you'll have 4 questions, and you'll choose 3 of them. Each is worth 10 points. I'm just going to go ahead and solve that now. So we want to ask which object is going faster, and that's going to be object B. And the reason we know that is that when we look at how the two objects move from their position graphs, B is actually the steeper of the 2 position graphs. And if you remember, a steeper slope means the object is moving faster. Now, we're going to go ahead and actually prove our answer by getting the velocity of each object. Now, the velocity is calculated from the position graph by getting the slope. And to do that, I'm going to take the rise over the run. So I have this point 80, and I have this other point up here, which is 0, 16. And so I'm going to take y2 minus y1, that's 0 minus 16, over x2 minus x1, which is 8 minus 0. And when we simplify this, that's going to give us negative 2 centimeters per second. All right, now I'm going to go ahead and I'm going to calculate the velocity of A. Once again, I'll label its endpoint. So this is 10 at a position of 0 centimeters. And then I'm actually starting at time equals 0 with a position of 10 centimeters. So when I go ahead and actually calculate that rise over run, that's going to be 0 minus 10 over 10 minus 0. And that's going to give me negative 1 meters per second. So we can clearly see that this speed is faster than that speed. Remember, the negative sign in this case, it doesn't mean less than. It means that we're actually going in reverse. Now let's go ahead and get the displacement of each object after 2 seconds. To do that, so I'm just going to say the displacement for object B. So I go to this graph up here, and at 2 seconds, it looks like at 2 seconds, the object is at 12. So to get the displacement, that's just going to be 12 minus 16. I'm basically taking the rise of the object, just this part here, and the rise over run calculation. So that's negative 4 centimeters. And then for object A, let's get its displacement. So at 2 seconds, it looks like this object is actually, at 2 seconds, the object is at 8 centimeters. And so what we're getting is XA is going to be 8 minus 10, which is negative 2 centimeters of displacement. Now we're going to go ahead and plot the velocity of each object below. So we have that the velocity of object A is negative 1 meters per second, and the velocity of object B is negative 2 meters per second. So let's go ahead and actually draw those now. So for A, it's just a straight line across because the slope never changes. So that's object A. And for object B, similarly, it's negative 2 centimeters per second. Its slope never changes, so that means its speed never changes, so we just draw a flat line. So we have basically drawn the velocity of each object. To do that, once again, you just plot the slope that you calculated in part B. So that's problem number 1, and we'll take a look at problem number 2 in the next video.